In this video, we will be looking at rational expressions. So first we need the definition. A rational expression is a fraction with a polynomial in the numerator and a polynomial in the denominator. So we have a couple examples here. First up, 3x plus 2 over 2x minus 8. Then we have x plus 7 over x squared plus x minus 6. However, something that's going to be special about these rational expressions is that they have variables in the denominator. Since there are variables in the denominator, it's possible for a rational expression to be undefined. We know that we can't divide by 0, so we need to make sure that the denominators of these fractions are never 0. So like I said, rational expressions are undefined when the denominator is equal to 0. So the domain of the rational function is all real numbers except for those excluded values. So we're going to take these two rational expressions and see if we can find the excluded values, meaning the values that x cannot be. So all we need to check is to make sure our denominator is not equal to 0. So for this first one, I need 2x minus 8 to not be equal to 0. If I add the 8 over, I get that 2x cannot be equal to 8. And if I divide by 2, I get that x cannot be equal to 4. So the excluded value is 4. That's the one number that x cannot be equal to. In the second one, we're looking at x plus 7 over x squared plus x minus 6. Again, we know that the denominator cannot be equal to 0. So I'll say x squared plus x minus 6 cannot be equal to 0. That is a quadratic expression on the left-hand side, so I can factor it. That is going to factor into x plus 3 times x minus 2. That cannot be equal to 0. So we get that x plus 3 cannot be equal to 0, meaning x can't be a negative 3. And x minus 2 cannot be equal to 0, so x cannot equal a positive 2. So this time we have two excluded values, negative 3 and positive 2. So for excluded values, we're just trying to find the numbers that x cannot be equal to, and x cannot be equal to these values because that would mean we're dividing by 0. Now we're going to simplify some rational expressions. It's also another way of looking at dividing polynomials. The way we're going to do this is factoring the numerator and denominator, and then we're going to cancel out any common factors. So in the first one, I'm looking at x squared plus 2x minus 8 over x squared plus 10x plus 24. I'm going to see if I can factor my numerator and denominator. So in my numerator, that will factor into x plus 4 times x minus 2. My denominator is going to factor into x plus 4 times x plus 6. I can divide out any factors that are identical in the numerator and denominator. They both have an x plus 4, and that leaves me with x minus 2 over x plus 6. So that's how this expression simplifies. Next up, we're looking at an x squared minus 1 over x squared plus 6x plus 5. That numerator is a difference of squares, so it's going to factor into x plus 1 times x minus 1. The second one, we're looking at x squared plus 6x plus 5. That factors into x plus 5 times x plus 1. I can divide out the common factor. We have an x plus 1 in our numerator and denominator. So that leaves us with x minus 1 over x plus 5. Simplifying rational expressions is going to be huge because it's going to help us when we're multiplying and dividing these. So we're going to start with multiplying. We're going to start the same way that we started with simplifying. We're going to factor out all the numerators and denominators. Then we're going to divide out any common factors. And then whatever's left, we're going to multiply together. The numerators are going to be multiplied and the denominators are going to be multiplied. I'm going to break out a whiteboard so I have a little bit of extra room. First up, we have a 2x squared minus 10x plus 12, and I want to factor that. First, I need to check for a greatest common factor, and there's a greatest common factor of 2. And if I factor out the 2, then I'm left with x squared minus 5x plus 6. Well, I can factor that trinomial, so this is going to factor again into 2 times. To get my x's out front, I need a -2 and a -3. So that's my first numerator. My first denominator is x squared minus 2x minus 3. That's a trinomial. My greatest common factor is just 1, so I don't do anything there. But I can factor it into x minus 3 times x plus 1. My second numerator is x squared minus 1, which is a difference of squares. It factors into x plus 1 times x minus 1. And then my second denominator is a 2x squared minus 8. First, I can factor out a greatest common factor of 2, which leaves me with x squared minus 4 in parentheses. And then x squared minus 4 is a difference of squares, so I can continue factoring that into x plus 2 times x minus 2. But don't forget we have this 2 out front. He's important too. So now I'm going to go ahead and replace all of the expressions that I have with their factored equivalents. So I'm going to be able to rewrite this as 2 times x minus 2 times x minus 3 over x minus 3 times x plus 1 times x plus 1 times x minus 1 over 2 times x plus 2 times x minus 2. Now that everything's factored, I can go ahead and start simplifying. It doesn't matter if our factors that are common are in the same or different fractions. As long as one is in a numerator and one is in a denominator, they're going to be able to divide out. That's because when we multiply fractions, we do numerator times numerator and denominator times denominator. So anything in a numerator that matches with a denominator, we're going to be able to divide out. I have 2's that divide out. I have x minus 2's that divide out. I have x minus 3's that divide out. And I have x plus 1's that divide out. All that's left is an x minus 1 in my numerator and an x plus 2 in my denominator. This is how that expression simplifies. So that's multiplying rational expressions. Next up, we're going to divide. Well, there is something we need to remember about dividing fractions that's very important. And it's that dividing is the same as multiplying by the reciprocal. The way a lot of my students remember this is keep, change, flip. So we keep the first fraction the same. So this is x squared minus 2x plus 1 over x cubed plus x. So that's the keep. Then we change from division to multiplication. And then flip, we're going to flip the second fraction, 3x squared plus 3 over x squared plus x minus 2. Now we are no longer dividing, we're multiplying, and that's something we already know how to do. So I just need to factor everything and then work on multiplying. First up, we have an x squared minus 2x plus 1. That factors into x minus 1 times x minus 1. We have an x cubed plus x, which has the greatest common factor of x, leaving me with x squared plus 1. You may want to try to factor that x squared plus 1, but it is not a difference of squares. That's the only thing we know how to factor that's a binomial is a difference of squares, and this isn't that, so it's stuck. Our second numerator is 3x squared plus 3. There's a greatest common factor of 3 that I can factor out, leaving me with x squared plus 1 in parentheses. And then my second denominator, x squared plus x minus 2, factors into x plus 2 times x minus 1. So I'm going to go ahead and write everything in factored form. So that is x minus 1 times x minus 1 over x times x squared plus 1 times 3 times x squared plus 1 over x plus 2 times x minus 1. Then, just like we did on the first multiplication problems, we're going to be able to divide out any common factors between a numerator and a denominator. So I have an x minus 1. I don't have another x minus 1 in my denominator, so that one stays. I don't have a factor of 3 to divide out, but I do have an x squared plus 1. So in the numerator, I have an x minus 1 in parentheses times 3. I'm going to write the 3 out front because it looks nicer to me. So I get 3 times x minus 1 over x times x plus 2. If you want to, you can multiply the 3 through the parentheses and the x through the parentheses, but you don't have to. It's okay to leave it like this. So since we've done multiplying and dividing, now we need to work on adding. Just like we would with standard fractions, something like 2/9 plus 3/9 equals 5/9. If the denominators are the same, we just need to add together the numerators and the denominator stays the same. All right, so in this case, I have 2x plus 7 plus x plus 8 over x squared plus 6x plus 5. Since I have the same denominator, I can just add straight across my numerators. I have 2x plus 7 plus x plus 8 over that denominator, x squared plus 6x plus 5. I'm going to go ahead and combine my like terms. That gives me 3x plus 15 over my denominator, x squared plus 6x plus 5. But just like we do with other fractions, we need to see if this reduces. And to see if it reduces or simplifies, that means we have to factor it. So in my numerator, I can factor out a greatest common factor of 3, which leaves me with x plus 5. In my denominator, that factors into x plus 1 times x plus 5. And you'll notice I have those x plus 5s that divide out. This reduces to just 3 over x plus 1. So everything is the same between regular fractions and rational expressions. We have the same ideas. It's just that it looks a little bit more complicated because we have variables involved. But all of the same ideas are there. Next, we're going to try one with subtracting. They still have the same denominator, so we don't have to worry about that. What we do have to worry about is the fact that this negative is going to have to get distributed to the entire second numerator. So when I combine these two fractions together, I'm going to have 4x minus 10 minus, in parentheses, x minus 4 over the common denominator, x minus 2. If I distribute my negative through, I'm looking at 4x minus 10 minus x plus 4 over x minus 2. I can combine my like terms, giving me 3x minus 6 over x minus 2. Now I need to see if this simplifies. In the numerator, I can factor out a 3, which leaves me with x minus 2. In the denominator, I have x minus 2. So I have that x minus 2 in common. It divides out. I'm left with 3 in my numerator. This simplifies just to 3. That's it. But as we know, adding and subtracting fractions, we don't always have the same denominator. So first, we're going to have to learn how to find a common denominator. The same process can be used for regular fractions as we do for rational expressions. It just might look a little bit different. So if we need to find a common denominator first, we are going to start by factoring each denominator completely. Then we're going to list, the factors of the first denominator, and then we're going to add to that list any factors from the other denominators that aren't already on our list. And this will make more sense once we have an example to work with. So whatever is contained in our list in the end is going to be our least common denominator. So starting off, we're looking at 7 over 5x squared plus 15x and 9 over x squared plus 6x plus 9. First, we need to factor our denominators. This first denominator has a greatest common factor of 5x. And if I factor that out, I'm left with x plus 3. My second denominator factors into x plus 3 times x plus 3. So for my least common denominator, I need to list every factor from my first denominator. There's a 5, an x plus 3. That's my entire first denominator. Now I'm going to go through my next denominator and see if each of my factors are on my list. X plus 3, it's already there. Another x plus 3. I don't have that, so I need another x plus 3. That full list is going to be my least common denominator. In the second example, we're looking at 2 over 3x minus 2 and 7 over x plus 9. Unfortunately, neither of these two denominators are going to factor. So our least common denominator here will be the first denominator, 3x minus 2, because it doesn't factor. X plus 9 isn't on my list, so that's going to be my second factor. So sometimes your least common denominator is just going to be your denominators multiplied together. No fun, but it does happen. All right, so now we have an example that we can work with. We're going to find the least common denominator. We're going to rewrite each term as an equivalent term with the least common denominator as the denominator, and then we'll add or subtract the numerators. Before we actually do this, I want to do one regular fraction addition where they don't have the same denominator, because I think we'll be able to make a lot of connections. So I would like to take, let's say 5/12 plus 7/8. So before we can add them, we need a common denominator. So one way we might do this is ask ourselves, what's the smallest number that 12 and 8 both go into? But just to show how this is similar to rational expressions, I'm going to do this a slightly different way. I'm going to find the prime factorization of each. 12 is 4 times 3, and 4 is 2 times 2. So that means the prime factorization of 12 is 2 times 2 times 3. I'm going to do the same thing for 8. 8 is 4 times 2, and 4 is 2 times 2. So 8 is 2 times 2 times 2. So following the same idea as we were with rational expressions, for my least common denominator, I list all of the factors from my first expression, 2 times 2 times 3. Then I go through my second one and add anything to the list that isn't there. A 2 I have, a 2 I have, another 2 I don't have. So my least common denominator is 2 times 2 times 3 times 2, which is 24. Yes, we could have gotten there by saying what is the smallest number divisible by 12 and 8, and that works for fractions, but when we're working with rational expressions, that might not be so clear. So now that we know our least common denominator is 24, we need to get both of our fractions to have a denominator of 24. Starting with 5/12, I need it to have a denominator of 24. To get from 12 to 24, I need to multiply by 2. So to get the equivalent fraction, I need to multiply my numerator by 2, which gets me to 10. 7/8, I want to get to a fraction out of 24. My denominator I need to multiply by 3. So I also need to multiply my numerator by 3, which gives me 21. So that means I can go back and rewrite this addition as 10/24 plus 21/24, which gives me 31/24. And that's how we add fractions that don't have the same denominator. We're now going to do that, but with rational expressions. I'm going to keep this handy so we can refer back to it. So in this example, we want to add x plus 3 over x squared plus x minus 2 plus 2 over x squared minus 1. First, I need to figure out what my least common denominator is going to be. And to do that, I need to factor both of my denominators. X squared plus x minus 2 factors into x plus 2 times x minus 1. X squared minus 1 factors into x plus 1 times x minus 1. So my least common denominator, I start with my x plus 2 and my x minus 1. I go to my next denominator. Is x plus 1 on my list? Nope. So I have to add it. Is x minus 1 on my list? Yes. Since it's just already there, I don't need to add it. So this is the denominator I want both of my fractions to have. So I want to take my fraction x plus 3 over, I'm going to go ahead and write it in factored form, x plus 2 times x minus 1, and I want to write it as the equivalent fraction that has the denominator x plus 2, x minus 1, x plus 1. So what it's missing right now is that x plus 1. So I need to take my numerator x plus 3 and multiply it by that x plus 1 that it's missing. That's its equivalent fraction. My second fraction is 2 over x squared minus 1, which we factored into x plus 1 times x minus 1. For its equivalent fraction, I'm aiming for a denominator of x plus 2, x minus 1, x plus 1. So I already have my 2. What I'm missing in my denominator is this x plus 2. So I need to multiply by x plus 2 in my numerator. So if I want to rewrite this addition, I'm looking at x plus 3 times x plus 1 over that common denominator of x plus 2, x minus 1, x plus 1, plus 2 times x plus 2 over that common denominator, x plus 2, x minus 1, x plus 1. So I have my fractions, they have the same denominator. That means I can just add together my numerators. So this is x plus 3 times x plus 1 plus 2 times x plus 2 over that common denominator, x plus 2, x minus 1, x plus 1. I'm not thinking I'm going to have enough room, so I'm going to go ahead and go on to some paper to keep going. I'm going to have to FOIL these first two terms together, or sorry, these first two binomials. And that's going to give me an x squared. Outside is plus x. Inside is plus 3x. Last terms is plus 3. And then I need to distribute my 2 through, which gives me a plus 2x plus 4 over that common denominator, x plus 2, x minus 1, x plus 1. I can combine my like terms, giving me x squared. X plus 3x is 4x. Adding 2 more is 6x. And then 3 plus 4 is plus 7. Over that common denominator of x plus 2, x minus 1, x plus 1. The question is, can that simplify? Well, if we take our a times c, 1 times 7, that's just 7. The ways we can multiply and get 7 are 1 and 7, or negative 1 and negative 7, and neither of those add to give me 6. So I'm done. This simplifies into x squared plus 6x plus 7 over x plus 2, x minus 1, x plus 1. All right, we have 2 more we're going to look at. Both of them are subtraction problems, but we're going to approach them the same way. First up, we have 2 over x minus 2 minus 3 over x plus 1. Well, neither of those denominators can factor, so our least common denominator is going to be x minus 2 times x plus 1. So that means my first fraction, it already has the x minus 2, so it needs an x plus 1. My second fraction already has the x plus 1, so it needs the x minus 2. So what I'm looking at is 2 times x plus 1 over x minus 2 times x plus 1 minus 3 times x minus 2 over x plus 1, x minus 2. Since they have the same denominator, I can put them together into 2 times x plus 1 minus 3 times x minus 2 over that common denominator, x minus 2, x plus 1. I can distribute through, so I'm looking at 2x plus 2 minus 3x plus 6 over x minus 2 times x plus 1. If I combine my like terms, that gives me a negative x plus 8 over x minus 2 times x plus 1. The best I could do with factoring the numerator would be to factor out a negative, but that would leave me with x minus 8 in parentheses, and that doesn't divide out with anything in the denominator, so I'm just going to leave it like this. Negative x plus 8 over x minus 2 times x plus 1. One more, we're looking at 1 over x squared plus 6x plus 5 minus 3 over x squared plus 2x minus 15. We need to factor both of our denominators. The first one turns into x plus 5 times x plus 1. The second one is x plus 5 times x minus 3. So that means our least common denominator is going to be the x plus 5 and the x plus 1 from the first denominator. X plus 5 is already there. Still need an x minus 3. So let's see what happens. My first fraction is already 1 over x plus 5 times x plus 1. What it's missing from the least common denominator is the x minus 3. So I'm going to multiply by x minus 3 in my numerator and denominator. In the second fraction, I already have 3 over x plus 5, x minus 3. So what I'm missing from that denominator is the x plus 1. So I'm going to multiply by x plus 1 in my numerator and denominator. Now that they have the same denominator, I can combine them into one fraction. We have 1 times x minus 3 minus 3 times x plus 1 over our common denominator, x plus 5, x plus 1, x minus 3. I'm going to distribute through my numerator, giving me x minus 3 minus 3x minus 3. That's over our x plus 5, x plus 1, x minus 3. I combine my like terms, giving me a negative 2x minus 6 over x plus 5, x plus 1, x minus 3. In the numerator, it looks like I can factor out a negative 2. That'd give me negative 2 times x plus 3, because we factor out the negative. My denominator is x plus 5, x plus 1, x minus 3. I don't have anything in common. This one's a plus 3, this one's a minus 3. I can't divide those out. This is my final answer. So some things you should be aware of is when we are multiplying or dividing fractions, we don't have to have a common denominator. We just factor everything and cancel it out. For adding and subtracting, we need that common denominator first. So make sure you're keeping that in mind as you're working these problems.